Assume that the number of network errors in a day is distributed as Poisson. The mean number of network errors experienced in a day is 1.8. What's the probability that in any given day? So again, the mean is over a day, and the question is also asked over a day. In any given day, less than 3 errors. So mean is 1.8 and x is less than 3. So again, let's see how we go to it. Stats, calculator, Poisson. Mean is 1.8. And x is less than 3, so less than 3. 0.7306. A new phone answering system is capable of handling 6 calls every 10 minutes. Prior to installing the new system, company analysts determined that the incoming calls to the system are Poisson with mean equal to 3 every 10 minutes. If the incoming call distribution is what the analysts think it is, what's the probability that in a 10-minute period, more calls will arrive than the system can handle? So mean is 3, mean is equal to 3, and you want the probability of more calls than the system can handle. So the system can handle 6 calls. So you want the probability of more than 6, because more calls than the system can handle. So x is greater than 6 and mean is 3. X is greater than 6. 0.0335. Last year, a person wrote 125 checks. Let the random variable x represent the number of checks the person wrote in a day. So now you see that's the situation I have been talking about, that the average is given over a year. So over a year, the person wrote 125 checks, but the question is asked about a day. So you have to convert that yearly average to a daily average. So if it's 125 checks in a year, then it will be 125 divided by 365, because in a year there are 365 days. So if you want the number of checks per day, you would divide the yearly checks by 365. So the mean in this case will be 125 over 365. 125 divided by 365. So they need a decimal, 3 decimal places. 125 divided by 365. 0.342. And the standard deviation, for Poisson, the standard deviation is the square root of the mean. So we take the square root of 0.342. No. Okay. Square root of 0.342. I keep hitting the square button. So second square root 0.342, 0.5848, 0.585, and the variance is the same as the mean, so 0.342. Remember, for Poisson, the mean and variance are equal, and standard deviation is the square root of the variance or the square root of mean in this case.